Hey everybody, welcome in. Today what we're going to be doing is we're going to be taking a look at grade 4 module 1 lesson number 13. And in this lesson what we're looking to do is use place value understanding to decompose to smaller units just once using the standard subtraction algorithm, and then we're going to apply this subtraction algorithm to solve word problems using tape diagram. I'm going to get into what decompose to smaller units means once we get down to letter D, letter E, G, H, and I. Now, I'm not going to do all of these. I'm only going to do the ones that are highlighted in yellow here. So our directions say, use the standard algorithm to solve the following subtraction problem. So we are looking at subtraction here. So when we subtract, we start from the top and we always work our way down. So we have to take this number here minus this number here. We always take the top minus the bottom. And when we set up these subtraction problems, notice that our larger number always goes on top. The smaller number always goes on bottom. And again, as always, lining up our place values. So these are set up for us, but those are just some general things to keep in mind as you're setting up your own subtraction problems. So we'll start in our ones place. 5 minus 2 is 3. 2 minus 0 is 2. 5 take away 5 is 0. And 7 minus 3 is 4 for a difference of 4,023. Now, in each of those situations there, our top number was larger than the number on the bottom. That's not going to be the case here for D, E, G, H, and I, but nothing we can't handle. So in our ones place, we have 5 minus 5, which is 0. And in our tens place is where we run into that dilemma, where it's no longer a larger number subtracted by a smaller number down here. And what you do not want to do is work your way back up, say, oh, well, I can't do 2 minus 3, but 3 minus 2 is 1. That's the incorrect way to do it. What you need to do is you need to use that place value understanding and regroup 10 from the next largest place value. So rather than having 6 hundreds and 2 tens, what we're going to do is we're going to regroup one of these hundreds for 10 tens. So instead of having 6 hundreds, we now have 5 hundreds, and we're going to take one of those hundreds and give it over here to the tens. So we already had 2 tens, and we know that 100 is equal to 10 tens, which makes 12 tens. That's how we create having a larger number up here on top. So now we can do our subtraction with 12 minus 3, which is 9. If we would have done it the incorrect way and just done 3 minus 2, we would have ended up with a 1 here. So you can see how that's a little bit different. We're still good over here in our hundreds place. Our larger number 5 minus 4 is 1. And 4 take away nothing is 4 for a difference of 4,190. Over here in letter E, again, starting in our ones place and working our way to the larger place values, just in case we do need to regroup. 0 minus 0 is 0. Now we have a smaller number up here on top with a 7 on the bottom, so I can't do 0 take away 7, so I need to regroup from the hundreds place. So instead of having 5 hundreds and 0 tens, we're going to think about it as 4 hundreds and 10 tens. 10 tens makes 100, so we're not changing the problem, we're just sort of looking at it in a little bit of a different way. Now 10 minus 7 in our tens place is 3. 4 minus 4 is 0. And 6 minus nothing is 6 for a difference of 6,030. For letter G, again, starting in our ones place, 0 minus 0 is 0. 4 minus 3 is 1. 6 minus 6 is 0, comma. Now we have a 3 in our thousands, and we need to take away 4 thousands, and 4 thousands is greater than 3 thousands. So we need to regroup one of the 10 thousands from the two that we have for 10 thousands to make 13 thousands, and now we can subtract 4 away from 13 to make 9, and 1 minus 1 is 0 to make 9,000 10. For letter H, we have 5 take away 5, which is 0. 2 take away 1, which is 1. 9 minus 8, or 9 take away 8, which is 1. Now we run into that dilemma again, where we have 1 in our thousands and a larger number here on bottom. So we need to regroup from, in this case, our 10,000. So we're going to regroup 3 10,000s for 2 10,000s and 1,000, 10 thousands, plus the one we already have to make 11. So 11 take away 4 is 7. 2 minus 0 is 2. And 4 minus 2 is also 2, to make 227,110. And the last of our what I like to call straight up subtraction problems, without much of a context of a word problem, just practicing the skill, letter I. So 5 take away 5 is 0. 2 take away 0 is 2. 9 minus 7 is 2. 9 minus 1 is 8. Now over here we run into our dilemma where we have more on the top. So 1 take away 2 I cannot do with subtraction, so I need to regroup from the 100,000s place, and that's going to give me 10 extra 10,000s, plus the one that's already here makes 11. So 11 minus 2 is 9, and 1 minus 1 is 0, for a final difference of 98,220. Moving down to number 2, we're going to add a little bit of context and put these into some word problems. So the directions say, draw a tape diagram to represent each problem, use numbers to solve, and write your answer as a statement. And then, as always, we're going to check our answers. So I really like number 2 because it really forces us to think about the relationship between addition and subtraction. Addition and subtraction are inverse operations, which means they sort of undo each other. And the verbiage here in number 2 is all addition. So sometimes I've seen some students, take a look at this problem and they think that we need to add because we see, the word added. What number must be added to this to result in a sum of 25,884? A lot of addition type words. But the question asks, what number needs to be added to 13,875 to result in a sum of 25,884? So if I was to write this as an equation, it would look like this. What number, so something, must be added? So we're going to add 13,875 to result in a sum of 25,884. So in order to undo addition, we actually need to use subtraction. And to show this as a tape diagram, it would look like this, where the sum is 25,884. So that's going to end up here. That's our whole. And here's our two parts. This is a part, and this is a part. So we don't know what this part is here, but the other part is 13,875. Now, how do we find this missing part? We need to use subtraction. We're going to take 25,884 and subtract 13,875. Now in our ones place is where we run into that dilemma. Again, I had to set this operation up here on my, by myself. It wasn't like, these up here where it's set up for me. So again, I need to make sure that my larger number is on top, smaller number is on bottom, and I'm aligned with my place value. So I'm subtracting ones from ones, tens from tens, all that sort of stuff. So right here in my ones place, I have 4 ones and I need to take away 5 ones, and I can't because I don't have enough. So here's where I'm going to need to regroup. I'm going to need to regroup 8 tens for 7 tens and 10 ones, but I already have 4 ones to make 14 ones. So 14 minus 5 is 9. 7 minus 7 is 0. 8 minus 8 is 0. 5 minus 3 is 2. And 2 minus 1 is 1. So I should be able to plug in 12,009, add it to 13,875, and get 25,884. And since it tells us to check our work, we'll use our addition to check our subtraction. So I'll do 13,875 plus the difference, and I should end up with this sum over here, plus 12,009. 5 plus 9 is 14. 1 plus 7 is 8. 8 plus 0 is 8. 3 plus 2 is 5. And 1 plus 1 is 2. Does this number match that number? Yes, it does. So we're on the right track. So just to put this in a sentence for us real quick, we could say or I guess we could say 12,009 could be added to 13,875 to make 25,884. And there we go. Now I'm going to do something slightly different here with number 3. I'm not going to use a tape diagram on this one because I think this is a great question to illustrate how we could use a number line to model subtraction. So number 3 says, artist Michelangelo was born on March 6th, 1475. Author Mem Fox was born on March 6th, 1946. How many years after Michelangelo was born was Fox born? So again, I'm going to use a number line to represent this problem here. So we have Michelangelo, and we're going to put him right here. This is, the day he was born, and we'll say that this is March 6th, 1475. So really, the day is kind of insignificant. I'm really looking at the relationship between the years. So 1475. Now, time passes, time passes, time passes, and eventually, we'll say about here, this is when our author Mem Fox was born, and this was in 1946. So what we need to figure out is how much time or how many years passes between 1475 to 1946. So if I were to use a tape diagram to model this problem, we would have when Mem Fox was born is up here, is 1946. We know that Michelangelo was born in 1475. And this question mark here, what we're trying to figure out is the amount of time between 1475 and 1946. And of course, we can use subtraction to figure that out. So we'll take 1946 and 1475, and we're going to subtract. So instead of saying it how we normally say years, 1946 and 1475, we're going to try and transition to saying these numbers the way we would normally say it, which is 1,946 minus 1,475. 6 minus 5 is 1. In my tens place is where I run into my sort of regrouping dilemma, where I have a smaller number 4 here on top and I need to take away 7. So I'll regroup from my hundreds place. I'm going to regroup 9 hundreds for 8 hundreds and 10 tens. And I already have 4 tens, which makes a total of 14 tens. And 14 minus 7 is, of course, 7. And 8 minus 4 is 4, and 1 minus 1 is nothing. So again, in order to check my subtraction, I can use addition by taking the difference that I found and adding it to the smaller number, and I should end up with my larger number here. So I'll take 1475 or 1475 plus the 471 years, and my answer here should end up as 1946 or 1946. So 5 plus 1 is 6. 7 plus 7 is 14. Down the 4, carry the 1. 1 plus 4 is 5. Plus 4 is 9. And 1 plus nothing is 1. And 1946, 1946 matches here and matches here. So I know that I am correct. So to use a sentence to answer, we could say, Michelangelo was born 471 years before Mem Fox. Or I could say something along the lines of, I can kind of turn around and say Mem Fox was born 471 years after Michelangelo. A couple different ways I could phrase my sentence in order to answer the question being asked. Number 4 says during the month of March, 68,025 pounds of king crab were caught. If 15,614 pounds were caught in the first week of March, how many pounds were caught the rest of the month? So, one more time. During the month of March, so we're looking at total amount of weeks, days in March, there were 68,025 pounds were caught in the whole month. So this is like my total. The total amount of pounds in the month of March is 68,025 pounds. Now, 15,614 pounds were caught in just the first week. And we're asked to find, I'll change my color for this. We are asked to find how many pounds were caught the rest of the month. So this is a really good illustration of like the part whole model, or like a tape diagram, where we have our whole. We know how many pounds of crab were caught in the entire month of March. In the whole month, 68,025 pounds were caught, and we're going to break that up into two parts. We know how many pounds were caught in the first week, which is 15,614. Again, this is the first week. And this is the rest of the month. And of course, this is what we don't know. But since we have our total amount and we have a part, we can use subtraction to find the other part. So we'll take our 68,025 pounds that was caught in the entire month, and we're going to subtract off the amount that was caught in just the first week, and that will leave us with how much was caught the rest of the time. So 5 minus 4 is 1. 2 minus 1 is 1. 0 minus 6, here's where I need to regroup because I have a smaller number on top compared to my larger number. So I'm going to regroup 8 thousandths for 7 thousandths and 10 hundredths. And since I don't have any hundreds here, this is just going to be a 10. So we're regrouping 8 thousandths for 7 thousandths and 10 hundredths. 10 minus 6 is 4. 7 minus 5 is 2. And 6 minus 1 is 5. So 52,411 pounds were caught the rest of the time. We'll use addition to check our work. So we should be able to take our difference of 52,411 and add it to the amount of pounds that were caught in the first week. So think about it. If 15,614 pounds were caught in the first week, and 52,411 pounds were caught the other couple of weeks in March, we should end up with how much or how many pounds of crab were caught in the entire month of March. 1 plus 4 is 5. 1 plus 1 is 2. 6 plus 4 is 10. 1 plus 2 is 3. Plus 5 is 8. And 5 plus 1 is 6. 68,025. 68,025. That's the number we started with here. So again, to put this in a sentence, we could say 52,411 pounds of crab were caught in the other few weeks of March. And last but certainly not least, it says James bought a used car, good investment, after driving exactly 9,050 miles. Go back to yellow. After driving exactly 9,050 miles, the odometer read 18,064 miles. What is the odometer reading when James bought the car? So if you're not sure what an odometer reading is, that's the number on the car that tells you how many miles it's been driven. And again, this car is used. So somebody had this car and was driving it before James bought it, and they used the car and they drove it. So that's really what we need to figure out, is we need to figure out how many miles the car was driven before James bought the car. So the odometer reading now, to use a tape diagram, the number on the car now, which says the total number of miles it's been driven, is 118,064 miles. Now they tell us that James drove 9,050 miles. So this part over here, the part we don't know, is how many miles was on the car before James started driving it. So again, we'll use subtraction to figure this out. So we'll take our odometer reading now, which is 118,064, and we're going to subtract 9,050. Again, remember to line up your place values on the right-hand side. So your ones line up with your ones, your tens line up with your tens. So in this case, since this is a 6-digit number and this is a 4-digit number, this 9 is in the thousands place. I need to line it up with the 8 in the thousands place. So 4 minus 0 is 4. 6 minus 5 is 1. 0 minus 0 is 0. And here's where I need to regroup. So 8 minus 9 is something I can't do. So I'm going to regroup this 10,000. So I have no 10,000s left. And I'm going to regroup that for 18,000s. So 18 minus 9 is 9. 0 minus nothing is 0. And 1 minus nothing is 1, to make 109,014. So that should be the amount of miles that was driven before James bought the car and drove an additional 9,050 miles. Again, we'll use addition to check our work. So we'll take our difference that we just found, and what we're doing is we're seeing if this is the right answer. That's really what we're doing here. So 109,014 plus the amount that James drove, which is 9,050. And we should end up with the odometer reading on the car, which is 118,064. So 4 plus 0 is 4. 1 plus 5 is 6. 0 plus 0 is 0. 9 plus 9 is 18. 1 and 1. So we know our answer is correct. And to put it in a sentence, we could say there were 109,014 miles on the car before James